So welcome back to our video module on 2 to the k design. In our previous video, we looked at 2 different factors. So this is 2 to the second design. And we found the basic ways of, writing it down and talking about it intelligently, where we use AB++, that type of thing. And the question I want to ask today is what happens now. I mean, that's nice for a square, but then what do we do if we want to do a third term? Like, let's say we want to do a fast and a slow, a third factor. How do we handle that? Today, we're going to be introducing the idea of a 2 to the third design, how we represent it, and how to think about the options. So instead of doing a 2-dimensional object, what we're actually going to do is we're going to extend this and make this a cube, just like you would in your Cartesian coordinate system when you go into the z-axis. So let's do this and this and this. And this face, this yellow face, this is the low setting of C. So let's call this one, we'll keep it in red so you can see it, C. And low here, high here, likewise low here, high here. And so when we talk about the actual levels, let's say this one right here, let's take a look at where we're at in A. In A, we're high. So that's going to be a positive. In B, we're down here. We're on the base plane. We're in this plane right there. And for all of those, B is low. Take a look at C. C, we're in this back plane where if we were in our z-axis, once again, go to your Cartesian coordinate system, that would be high. So when we want to, so plus, minus, plus is this point right here. And in a similar way, here we've moved up to the positive B level. Do you see how that works? Where we're looking at this top area, which means that if we wanted to represent it, it would be plus, plus, plus. And of course, the next question is, well, how do we represent it using this notation? Well, here A is high and C is high, so we call this AC. We call this ABC. And likewise, you can do all the same things here, where here it's negative, plus, plus, so that means B and C are high. And then finally down here, you have negative, negative, plus, which means you just have C. Interestingly, these don't change, right? Because C is low there. If we wanted to do it properly, we'd probably add a minus here and a minus here, minus here, and a minus here. Finally, if we wanted to write this in our little grid that we made last time, where we made standard order, like I said, we alternate minus, plus, minus, plus. And how many of these are there going to be? Well, however many points there are in a cube, or how many corners there are, which is 8. So minus, plus, minus, plus. So when we do this standard order, this is the nice thing about it, is we just alternate every 1. And then for B, we're going to alternate every 2, minus, minus, plus, plus, minus, minus, plus, plus. And then for C, we're going to alternate every 4. So actually, I'll give you a secret. That's alternate every 2 to the 0, every 2 to the 1, every 2 to the squared. I don't want to confuse you, but hopefully that clarifies it. And what you'll find is how can you get every single combination? And it's this way. All right, so now we've gone through and we've done standard order. Well, what's the notation that reflects that? 1 here, A, B, and then we're AB, and then C, AC, BC, and then finally ABC. And you can see that these two are exactly the same. As a matter of fact, this is simply a representation of this here. Now we've been able to expand our 2 squared to 2 to the third to see how we can represent this graphically, and also how to write this out in standard order, which becomes important when we actually want to do the experiment. I hope this has given a little clarity on 2 to the third, and I look forward to catching up as we explore 2 to the k going forward.